This last section of Chapter 1 deals with conversions. I have already introduced the basics of conversions to you because I think they are important for using metric prefixes properly. You might hear the term dimensional analysis. Dimensional analysis is basically making sure your units cancel out properly. Writing out your conversion factors will help you in this and future chemistry classes. If you have learned to do calculations some other way, like cross multiplication, please learn it this way instead. It is applicable to more problems and helps you double-check your answers. Doing conversions with squares or cubes can be tricky. You will use a normal conversion factor, such as 1 centimeter equals 10 to the minus 2 meters. But you will have to square or cube the whole conversion factor. That means not only are the units squared or cubed, but the numbers inside the conversion factor get squared or cubed as well. For example, if we want to convert 27 square centimeters to square inches, first we start out with the known quantity, 27 square centimeters. Then we write a normal conversion factor from centimeters to inches. So centimeters goes on the bottom and inches goes on the top. We fill it in with the numbers in the equality. 2.54 centimeters equals 1 inch. Then we are going to square the whole conversion factor because we need to go from square centimeters to square inches, not just centimeters to inches. When we square the whole conversion factor, the 2.54 in the denominator gets squared. So we will do 27 divided by the square of 2.54, which gives us 4.2 square inches. 73 square millimeters is equal to how many square centimeters? Is it A, 0.73 square centimeters, B, 7.3 square centimeters, C, 0.00073 square centimeters, or D, 7.3 times 10 to the minus 9 square centimeters? To solve this problem, probably the easiest way to set it up is to pretend there aren't any squares in it at first. So if I were going to go from millimeters to centimeters, I would go from millimeters to my base unit of meters, and then from meters to my base unit of centimeters. So again, I start out with a number I'm given, 73, and let's just pretend for now that it's only millimeters. We would go from millimeters to meters. Millimeters would go on the bottom to cancel out, meters on top since we're trying to solve for that as our intermediate. And then I can string them together. So I'm going to do my second step, going from my base unit of meters to my final prefixed unit of centimeters. So then I would put a 1 next to my prefixed units and my power of 10 next to my base unit. My power of 10 for milli is 10 to the minus 3, and my power of 10 that corresponds to centi is 10 to the minus 2. And notice that they go on opposite sides of the conversion factor from that prefix. So centi is on top and the 10 to the minus 2 is on the bottom, for example. So this would get me from millimeters to centimeters, but I want to go from square millimeters to square centimeters. So I'm going to need to square each of my conversion factors. So I'll put a parenthesis and put a square, and then some more parentheses around my second conversion factor and another square. So you have to be careful that the square that's on the outside of the parentheses applies to the units and it applies to any numbers that are within the parentheses. For example, we're going to have to square this 10 to the minus 3, and we're going to have to square this 10 to the minus 2. So we could write it as 73, and then when we square 10 to the minus 3, we get 10 to the minus 6. So we're multiplying by that. And then as you're putting it in your calculator, you could divide by 10 to the minus 4. 2 times 2 is 4, so we 10 to the minus 4 on the bottom. Or if you wanted to, you could put this into the numerator and multiply. So we could do 73 times 10 to the minus 6 times 10 to the positive 4. Either way, you get the same answer. This way allows me to do it in my head. So if I do 4 minus 6, that gives me minus 2. So I would have 73 times 10 to the minus 2, or in other words, 0.73. And my units are going to be square centimeters. So millimeters squared cancels out with millimeters squared. Meters squared cancels out with meters squared. We get square centimeters as our units. And we end up with answer choice A. I should also mention that if you're not given a multiple choice problem and you're just writing out an answer, do not give me a number that's not in proper scientific notation. So don't give me 73 times 10 to the minus 2 as an answer. You could give me 7.3 times 10 to the minus 1, or you could give me 0.73. What is the height in millimeters of an object that is 6 feet 11.50 inches tall? You were given some conversion factors. 1 foot equals 12 inches, and 1 inch equals 2.540 centimeters. You are expected to have your metric prefix table memorized to do the centimeter to millimeter conversion. Is the answer A, 3.042 times 10 to the minus 3, B, 0.3042, C, 212.1, or D, 2121? Our first step in solving this one is getting the feet into inches. So we know that 1 foot is equal to 12 inches. So if we have 6 feet and there are 12 inches in 1 foot, then we have 72 inches in 6 feet. We also have an additional 11.50 inches. So 72 plus 11.50 gives us 83.50 inches total. Now we can use some conversion factors to go eventually from inches into millimeters. But most people don't know a direct conversion to do that. But I do know a conversion to go from inches to centimeters. And then we can go from centimeters to meters and then meters to millimeters. So I'll take my 83.50 inches that we're starting with, and I'm going to have my first conversion factor with inches on the bottom to cancel out with the inches that we're starting with. And since I know an inches to centimeters conversion factor, I'm going to first convert to centimeters, so I'll put centimeters on the top. And we know 1 inch is equal to 2.540 centimeters. Then we're going to go from centimeters into our base unit of meters. So we'll use 1 next to the prefix unit, and our power of 10 for centi is 10 to the minus 2. Then we'll go from our base unit of meters into our final prefixed unit of millimeters. So we put 1 next to our prefixed unit of milli, and the power of 10 for milli is 10 to the minus 3. And again, that goes on the opposite side of the conversion factor from the prefix because they mean the same thing.
So we're going to go 8.350 times 2.540 times 10 to the minus 2, and then we will divide by 10 to the minus 3. So when we do all that in our calculator, we come out with 2120.9 millimeters. And we can round that to 2121, which is D.